This is our second recitation and the last problem, problem 6. For this problem, we will have electron with charge Q naught, which is 1.6 times 10 to minus 19th coulombs. And this electron is released from rest. This is important. This electron is released from rest in a region with constant electric field. This electric field is pointing to the left. So if I have X to the right, then electric field will be in this direction. And magnitude of electric field is given. It is 3 times 10 to the 4th newtons per coulomb. And direction is along negative direction of X. So it is in minus Ix direction. I put minus Ix. We need to answer 2 questions. Let's start with the first one. First question is, what is the force exerted on electron in this electric field? We know that if we have electric field created in some region in space and we put a charged particle there, then the force exerted on the charged particle is charge Q times electric field. So if charge is positive, then the force is in the same direction as the electric field. If charge is negative, then force will be in opposite direction to the direction of electric field. Let's apply this formula to our situation. Force exerted on Q naught is Q, which is, I forgot to put minus here. Electron has negative charge. So I have Q naught, which is minus 1.6 times 10 to minus 19th coulombs. This is Q, times electric field, which is minus 3 times 10 to the 4th newtons per coulomb Ix, minus and minus plus 1.6 times 3, 4.8, times minus 19th plus 4 times 10 to minus 15. Coulombs, I have newtons. And this, we don't forget to show the direction, unit vector Ix. Or in other words, the magnitude of force will be 4.8 times 10 to minus 15 newtons to the right. The force will be Fq naught will be to the right. This will be the direction of force exerted on our negatively charged particle. We found the force. Now let's answer second question. And second question, that was the first question, find the force. And second question is, how fast this electron will be moving after traveling distance 10 centimeters. How fast, which means that we need to find final velocity. What will be the final V2, final velocity of electron? Which formula will we use? It's kinematics problem, right? So we have electron and mass of electron. We know this. Mass of electron is given. It is 9.11 times 10 to minus 31 kilograms. Distance traveled is 10 centimeters. I have x here, so my distance is x2 minus x1, 10 centimeters, or 0.1 meters. Force is constant, which means that acceleration is constant. I use second law, net force is ma. So force is constant, acceleration is constant, which means that I can use formulas for constant acceleration. And for the easiest way to solve this problem is to use this formula for constant acceleration. Final velocity squared minus initial velocity squared is twice projection of acceleration in x, and this is all in x direction, projections in x, 2ax, and then x2 minus x1. Initial velocity is 0 because it is released from rest. What will be the final velocity? I know x2 minus x1. All I need to find is ax. Ax is force Fx that we already found divided by m. So what will be our final velocity v2x? It will be square root, because it is v2 squared, of 2. Then it is Fx divided by m. And then x2 minus x1. x2 minus x1. x1 square root. So if I plug in numbers, I will do it here on the left. I will plug in numbers in f2x. f2x is equal to square root 2 times fx is 4.8 times 10 to minus 15 newtons. We found it in part A. Divided by m, that is given. It is 9.11 times 10 to minus 31 kilograms. So this is F over m, and then x2 minus x1 is 0.1 meters. 0.1 meters. If I calculate this number, I will get 3.24 times 10 to the 7th times 10 to the 7th. And the dimension is, of course, so let me do this. And dimension is meters per second. So we found the velocity of this electron after it traveled 10 centimeters in the electric field that was given. And this is the velocity that we calculated. 3.24 times 10 to the 7th meters per second.